All right, so today we're talking about arithmetic sequences. So this is a type of sequence. We'll learn about geometric sequences later, but today, arithmetic sequences. So you can go ahead, pause the video, and try the warm-up, and then come back and check your answers. All right, this one, write the first four terms of the sequence. So we have to find a sub 1 by plugging in 1 for n. You get -2. Plug in 2, you get 4. Plug in 3, you get -8. Plug in 4, you get 16. So there's your first four terms. B, write the next terms of the sequence and write a rule for the nth term. So whenever you see write a rule, that just means write an equation that represents what's going on right there. So let's first find our next term. So there clearly is going to be a 3 in the numerator. And then in the denominator, let's see what's happening in the denominator. So it looks like it's multiplying by 2, so 32. So we got 3 over 32. All right, so now I want to write a rule. So all of our rules should start with a sub n equals, and then you're going to say what pattern it's following. Numerator is 3, and then denominator, it's multiplying by 2 each time. So I'm going to say 2 to the nth power. Remember, if it's a multiple, if it's a multiplier, then you're going to use an exponential function with the base of that multiplier. Now we also have to check to make sure when we plug in 1, we get this term. When we plug in 2, we get this term, 3, so on and so forth. So when we plug in 1, do we get 3 over 2? Yeah, so that works as our rule. If we didn't, we could adjust it by changing this to maybe an n minus 1 or m plus 1, just so that it worked. All right, next one, write the series in sigma notation. So, sigma. All right, now I'm going to look for my pattern here. So this is plus 3, plus 3, plus 3. All right, so if it's plus 3, remember that is a linear equation, 3n. And then now I'm going to start by seeing if I plug in 1, if I get my first term. If I plug in 1, I get 3. If I plug in 2, I get 6. If I plug in 3, it's working. I get 9. Now I just have to know what would I have to plug in to get 75. So what would I have to plug in to get 75? If you don't know, you could always set the expression that you wrote equal to that number and solve. You get 25. So that would be my 25th term. All right, last part of the warm-up. Find the sum of the series. So we're plugging in 1, 2, 3, and 4, and we are adding those numbers up. So I'm just going to organize myself here. 1, 2, 3, 4. Plug in each one. Plugging in 1. 1 squared is 1 times 3 is 3. Plugging in 2. 2 squared is 4. 4 times 3 is 12. Plugging in 3. 3 squared is 9. 3 times 9 is 27. Plugging in 4, 4 squared 16, 16 times 3 is 48. Add those up. These two are 60. It's 87 plus 3 is 90. And there's my answer. Okay, so what we're talking about today is arithmetic sequences. So here's the definition of an arithmetic sequence. An arithmetic sequence has a constant difference d between consecutive terms. So this would be, for example, like plus 2, plus 2, plus 2, or minus 3, minus 3, minus 3. Okay, you can't do plus 2, then plus 6. That's not arithmetic. You can't do times 2, times 2, times 2. That's not arithmetic. So what we're going to do is we're going to look to see if it's arithmetic, if there's a common difference. If there is, we're going to write down what the difference is. So all that we're looking to see is what we add or subtract to get the next term and see if that pattern continues. So I asked myself, what do I do to a 5 to get it to be an 11? I add 6. So now we're going to see if that pattern continues. Plus 6, yes. Plus 6, yes. Plus 6, yes. So yes, this is arithmetic. And D is equal to 6, my common difference. All right, go ahead and pause the video and try B, C, and D. And then come back and check to see how you did. All right, looking at B, if I look at what's going on here, this is also plus 6. So I look to see if I plus 6 to get this, and it is not plus 6. It is plus 18, so no, this is not arithmetic. Now, you might have already right away said, oh, that's times 3 times 3 times 3, but I didn't ask you that. I asked you, is it arithmetic, meaning can you add or subtract a common difference? All right, next one right here. What do I have to do with negative 10 to get it to negative 6? I would add 4. Let's see if that pattern continues. Add 4, add 2. So nope, this is not arithmetic. This one here, what do I do to a 40 to get it to be a 32? I subtract 8. See if the pattern continues. It does. So yes, this is arithmetic, and the difference is negative 8. Okay, so now what we're going to do is we're going to learn how to write a rule, okay, for an arithmetic sequence. Now, arithmetic sequence, once again, they have a common difference. So like plus 2 plus 2 plus 2 plus 2, or plus 5 plus 5 plus 5 plus 5, or minus 6 minus 6 minus 6 minus 6, all right? And it can keep going on forever and ever if need be. Now, when I have a pattern like that, I know my equation is going to be linear. Okay, so how do we get that linear equation? To get that linear equation, we can use this rule right here. A sub n, or it is equal to, the equation that it's going to follow is equal to, you take the first term plus, and then n minus 1 times the difference. Then you can distribute, combine like terms, and you will get your rule. Okay, so we like to write it in slope-intercept form. A sub n equals the number times n plus your y-intercept. All right, so in order to write a rule, you need two things. You need the first term and you need the difference. Okay, so this says write an explicit formula, which just means write a rule for the nth term of the sequence. So first off, we have to check to see if it's arithmetic. So let's look for a common difference here. So how do I get a 32 to be a 47? I would add 15. Does that continue? It sure does. So we know that D is 15. To write a rule, once again, you need two things. You need the difference. 15, got that. And you need the first term. First term's 32, I got that. So now I can write my explicit formula. A sub n is equal to A sub 1, which is 32, plus n minus 1 times d, which is 15. So now what you're going to do is you're always going to put it in slope-intercept form. So you're going to distribute the 15. A sub n is equal to 32 plus 15n minus 15, and then combine like terms. So a sub n equals 15n. 32 and 15 is plus 17, and this is my rule that the pattern is following. You can see that now if you plug in 1 into this equation, you get 15 plus 17, which is 32. If you plug in 2 into this equation, you get 30 plus 17, which is 47. If you plug in 3, you get 45 plus 17, which is 62, so on and so forth. So it does work for this pattern. It always asks for a follow-up question, find a sub 12. To find a sub 12, I'm just going to plug 12 into my rule. 15 times 12 plus 17. You can use a calculator for this. This is not something that, this is not a chapter that you can't use a calculator for. This is all calculator. So we get a sub 12 is equal to 197. So if you don't have your calculator out, go ahead and get your calculator out so that you can do ones, as we move along here. All right, they're all a little bit different from each other. I want to make sure that you know how to do each of these. So this next one here says that one term of an arithmetic sequence, a sub 8, is 50. So this is saying that of the sequence, the 8th term is 50. The common difference is 2. Write an explicit rule for the sequence. So remember, in order to write a rule, you need two things. You need the common difference, which we gave that to you. And then you also need the first term, which we didn't give to you. So people always say, well, can I just keep subtracting 2 until I get the first term? Of course you can. But what happens if I give you the 732nd term? Do you want to do that 731 times? No, I don't think so. So what's another way of doing this? Well, what did I give you? I gave you your first term. And then I gave you your difference, and then I gave you your 8th term was 50. So I know that when I plug in 8 for n, I get 50 for a sub n. So what I can do is I can plug this into the equation along with my difference and solve for a sub 1. So I'm going to do, so once again, I'm using this equation right here. I'm going to do a sub n, which is I get 50. I don't know what the first term is, plus when I plug in 8 for n, and that's 8 minus 1 for the formula, times the difference, which is 2. So I have 50 equals a sub 1 plus 14. Subtract 14 from both sides, and I get my first term is 36. Now I know my first term, so I can erase that a sub 1 equals question mark. I'm going to put 36 there. And now I can write my rule. So I'm going to do a sub n is equal to a sub 1, which is 36, plus n minus 1 times 2. Distribute. 36 plus 2n minus 2. And then I have my rule. A sub n equals 2n plus 34. Okay, so we've seen how to do a problem if you're given the difference in the first term. That's the easiest. We've seen how to do a problem if you're given the difference and then a random term, right? Not the first term. So now what we're going to see is, what if I don't give you the difference and I don't give you the first term? Instead, I give you two other terms. In this case, the 5th term and the 10th term. All right, so what I want you to notice about an arithmetic sequence is that arithmetic sequences, if you look at their rules, they're linear equations. So arithmetic sequences have linear equations. Now, if I want to write a linear equation, all that I need to write in a linear equation, what are the two things I need to write an equation of a line? I need a point, and I need the slope of that line. So if you look at the slope of this line is, it's 2, the difference. If you look at the slope of this line was, it's 15, the difference. So I need to find the slope of this line so I can find the difference. So what was I given? I was given when the 5th term is 10. Or in other words, when I plug in 5 into my linear equation, I get 10. I also have that when I plug in 10, or my 10th term, is 110. So if you look at this, since it's an arithmetic sequence, this is why we can do it this way, is that we can use these 2 points, air quote there, to find the slope of the line. And then we can use either point, 5, 10, or 10, 1, 10, as our original point. So let's go ahead and do it. And there's more than one way to do this. You could also write a system to solve this, but this is the easier way. So I'm going to write my 2 equations so that I can solve this. No, I'm going to find the slope of this, and then I'm going to write the equation. All right, so first off, I need the slope of this line. M equals 110 minus 10, y2 minus y1 over x2, which is 10, minus x1, which is 5. So that is 100 divided by 5. So now I know the slope of this line is 20. That means D is 20. Okay, so now I need to write the equation of the line. So I'm going to use point slope form. Y minus y1 equals m times x minus x1. I'm going to pick one of my points as x1, y1. I'll just pick my first point because it's smaller numbers. So I'm going to do y minus y1, which is 10, equals m, which is 20, times x minus x1, which is 5. If I use 10 and 110 instead, once I distribute and combine like terms and get it equal to y, then I will have the same answer. Y minus 10 equals 20x minus 100, and then add 10 to both sides. So I get y equals 20x minus 90. Now, this is the equation of the line, but if you notice, our equations of our lines don't look like slope-intercept form. They don't look like y equals mx plus b. Instead, we're going to write our final answer as a sub n is equal to 20n minus 90. If you look at the answer key on my notes, I have a completely different way of doing this. I did it using elimination, writing 2 equations, solving for D, plugging it back in to solve for A1. But this way is less work, and I think it's more people get it. So there's my explicit rule for the nth term. And then now it has a follow-up question. It says, find the value of n when a sub n is 70. So now what I'm going to do is I'm going to change a sub n to 70. And I'm going to solve for n. So we add 90 to both sides. Divide by 20. And I get n is 8. So that is my 8th term. That means 70 is the 8th term. Okay, next one, find the 500th term of the sequence. And then it gives me the sequence -4, 1, 6, 11, 16. So I need to find the 500th term. If I ask you to find the 15th term, yeah, you can just continue the pattern. But 500th term, that's going to take a long time. So if I ask you to find the 500th term of this sequence that follows this pattern, that'd be easy. You just plug in 500. So what is that telling me? That's telling me that if I had a rule, I can just plug in 500. What are the two things I need to write a rule? I need the difference, and I need the first term. First term, -4. What's the difference? What do I do to a -4 to get it to be a 1? Add 5. Same thing here, add 5, add 5, add 5. So difference is 5. All right, let's write a rule. Remember, this is an equation of a line. A sub n is equal to my first term, -4, plus n minus 1 times d, which is 5. Distribute, combine like terms. That's, -4 plus 5n minus 5. So my rule is a sub n equals 5n minus 9. There's the rule. Now I can find any term I want to. I want to find the 500th term. So I'm going to do 5 times 500 minus 9. So the 500th term of this particular sequence, I do 5 times 500, which is 2,500 minus 9, 2491. Once again, you can use a calculator just so you don't make sure you don't make a mistake, but that one's pretty easy. All right, very last one here. Tommy earned $50,000 in his first year at his job. He gets regular raises on a yearly basis. In his second year, he earned $50,700. In his third year, $51,400. How much will he earn in his 25th year? So this is asking me, once again, what's the 25th term? If I had a rule, then it'd be very easy just to plug in 25, but I've got to come up with a rule in order to do that. So in order to write a rule, I need two things. I need the first term. Do I have the first term? Sure do, 50,000. I need the difference. Do I know the difference from year to year, how much more he's making? $700 more each year. Now I can write a rule. A sub n is equal to a sub 1, 50,000, plus n minus 1 times the difference, 700. Distribute 50,000 plus 700n minus 700. Combine like terms. So you have 700n plus 49,300. So there's your rule, and now you can find how much he makes in his 25th year. So we're going to do 700 times 25 plus 49,300. Once again, you can put that in your calculator, and you get that he'll make $66,800. Okay, yes, you could have just plugged in 25 right there, but I like seeing how to get the rule. It's really good practice. Okay, that's it for today. Go ahead and try out the homework. If you need to look back for your formulas, when you're first doing this, that's absolutely fine. But please make sure you're trying to have those formulas in your head and not just looking at them.